Hello everyone, so we are continuing with the second video of arrays in C++, and today we'll be discussing about searching and linear sort of array, that is searching of arrays and linear sort. So now just a brief recap of the definition of array. What is an array? So in the previous video I've explained the definition on that and how you declare an array, how you initialize an array, or what is an element, what is subscript, what is index, and so on. So here just in brief, again the definition of the array. So an array is a collection of homogeneous elements. So here the elements are referred by the variables are referred here as elements. So homogeneous, so same variables of the same type which are referred by a same name, and each element in an array is identified by its subscript or index. So since the all the variables will be referred by the same name, or all the variables will have the same variable name, so in order to identify them, you use what is called as a subscript or index, which is the number that is starting from 0 onwards to n numbers. So now, which is enclosed in square bracket. So within this square bracket, the index or the subscript to identify the elements will be written here. So arrays are data structure. Okay, so what is data structure we'll see later on in the next year. Okay, so just remember that arrays are data structure. So which shows you how the data are stored in memory. Okay, how they are obtained, like that. So which stores data in contiguous memory locations. So even in the even the values that are stored in array, the memory locations are in contiguous or like sequential, one after the other, like that. So the variables here are called as elements. Array index always starts with 0. It always starts with 0. Okay, so now we'll discuss what is searching arrays or linear search. So today we'll discuss about linear search and linear sort. Okay, so now suppose a programmer has to enter large amount of data, then the complexity of the program can be reduced by using array, right? So that was what which I've shown you in the first video, where you have suppose like to enter the marks or roll numbers, like that, right, of 5 students, like that. Then if suppose you have to enter the marks of 100 students, then you have to, the length of the program increases, the complexity of the program increases. So just by declaring like int num, right, int num, and within the subscript 100, then you can create 100 array elements. So like that you can reduce the complexity of program by using arrays. Now it may be needed to search for a particular value stored in the array, but of course um, using the array uh, does not solve the entire problem. Now it may be needed, okay, to search for a particular value stored in the array. So you may need to search for that particular search for a particular value in the array, right? Now since the array stores the data index wise, right, the data index wise, and the memory location is also in contiguous format. So now search, the one advantage is that searching for the data in the array, okay, it becomes much easier. However, it is a tedious task in terms of linear search. So here the process of comparing the search value, okay, the search value with each element in the array is called as linear search. So when you have to compare the value which you are searching with every element in the array, then it is called as linear search. So there is an advantage with having using array, and also the disadvantage. So in terms of linear search, is linear searching methods works for small array data or unsorted array. If the array, the size of the array is small, or if the arrays are unsorted. Unsorted means like the values are in random order. Okay, so the values which are stored like in this format. So this is an unsorted array, because you can see that the values that are stored are neither in ascending order nor in descending order. It is all in random order. So the search value must be compared with all the elements starting from the first element till the last element, or till the value is found in between the elements, right? So using this linear search method, it's illustrated by an example. So here, this is the index or the subscript. So that means starting from 0 to 7, you have exactly 8 elements, 8 array elements, or 8 variables to store these at 8 different values, right? So here, these are the values stored in array element 0. So in array element 0, 100 is stored. In array element 1, 25 is stored. In array element 2, 50 is stored. Still, array element 7, 30 is stored, right? So the index of these or the subscript of this array element is not 0 to 7 but 8, right? So now let's say that you are searching for this value 23, right? Now in linear search, what happens is that since the data is stored in according to the index in ascending order, right, starting from 0, 1 to 3, and also the memory location of where these values are stored are in contiguous format. Okay, so searching for the data becomes much easier in an array. However, when we use this linear search format, and especially when the values are unsorted, right, then what happens is that uh, it becomes a tedious task, because we have to start from the beginning of the first array element till the last array element, or until you find the search value. So here, when you are searching for 23, 23 will be compared with 100. Is 23 equals to 100? If no, right, then again you will move on to the second array element. Is 23 equals to 25, like that, right? Again it will move till it reaches, is 23 equals to 23, so that the search value is found in this index, or in this index, that is 6, or in position number 1 2 3 4 5 6 7, right? So that this is the form, this is how linear search is done. All right, so now let's see a program on linear search so as to make you understand much better. Okay, so program to input an array with 5 different integer values. So here we have an array name, that is num. So what we'll do is that we'll input an array num with 5 different integer values. So in this array called as num, 5 different integer random, or 5 random integer values will be entered and search for a particular value. So out of those 5 different values, you will search for a particular value. Now it may be out of these values, 5 different values, or it may be a different value which is not matching with this also, right? So it can be possible. So, and search for a particular value and its position in the array. So you also have to find the position in the array, in which position it lies. So based on that, if you see the program, okay, so here after the main function, within the main function body, the variables are declared here num, because the program question says array num, right? And then since you have to since this array num is used uh, to declare 5 different variables, integer variables, so here the subscript here is 5. Okay, and when you are using an array, you always use the counter variable, that is I. So you are declaring here, and this position equals to 0. Okay, this position equals to 0 is position equals to 0 is initialized, because you can see that, okay, uh, this is used in the program, right? Now it may be that here value represents the search value, right? So here, after declaring the variable, the next step is a prompt from the monitor screen. So cout enter 5 random integer values. So now using the for loop, you get to enter the values one at a time, right? So which is I equals to 0, so initialization is done for the counter variable, and initialization is done only one. Then that 0 is less than 5, so it is tested. So here is less than 5. It is not less than equal to, because if it is less than equal to, the loop will continue 6 times, right? So since I starts from 0, so that's why uh, I is equal to 0, because the array index always starts with 0, right? So when this test condition becomes false, the body of this for loop will be executed 5 times. So that means you get to enter at least 5 times here. Okay, so this is input 10 not 10 values, but input 5 values. Okay, so it depends on you. If you change this to 10, you will get to input 10 values, right? So based on that, num I means num0. So in num0, let's say that you enter so enter 5 random integer values, right? So let's say that in num0, when this for loop test condition is done, right, in num0, let's say you enter 12, right? Now after that, what happens is that then I gets incremented. So I gets incremented to 0 plus 1, 1. 1 is less than 5. So again it comes to the body of the for loop, C in num I. What now? The value of I is 1. So num1. So in num1, array element num1, you store 15. Okay, so similarly this will keep on going till it reaches num4 equals to 50. So by that time you can see that all the 5 array elements stores the value 12, 15, 7, 75 and 50, right? Now the next step is, after you do that, after you enter the value and after you store it in the array element, the next thing is you have to enter a search value, right? And then check out whether the search value is matching with these values that you have entered, and you have to find the position in the array, right? So that's why the cout prompt is enter the search value, and then using the C input stream, you enter the value and store it in this variable value. Okay, so suppose let's say that enter the search value, you are searching for 75, right? 75. Now after that the for loop begins, right? So again you have to compare all, because this for loop is, because you have to compare this value with all of the 5 numbers, that is 12, 15, 7, 75, 50, right? So it has to start from the beginning, just like this one, right? So it has to be, suppose this one you have to compare, so it has to start from the beginning. So similarly here also you have to search uh, for with, or compare with all the 5 different values, right? So that's why the for loop is necessary, and the loop will be same, I equals to 0, I is less than 5. And within the for loop, okay, now there is an if condition. So the boolean expression, if value equals to num I or num0, right? So you can see here the value, search value is 75, and here in the first case I equals to 0, right? I equals to 0, so 0 is less than 5. Yes, true, right? So now the if value is equals to num I. What is num I here, or num0? Num0 is 12, right? So what is the value? You have entered the search value of 75, right? So 75 will be compared with 12. Is it equal? No, since this is a relational operator, so it is false. So when it is false, the body of this if block does not execute. So that's why here it is written blank. Okay, then after that, since this is, just remember that this if test expression is inside the body of this for loop, right? So after the body of this for loop gets executed, the next step is the increment, that is I plus plus. So here I equals to 0 plus 1 equals to 1, because the value of I is 0, right? So now I becomes 1, right? Then so I becomes 1, then I gets tested with 5. So 1 is less than 5. Again after that, if value equals to num I. So now num I means num1, right? Now so again the value 75 will be tested with what is stored in num I or num1. Num1 stores the value 15, right? So now 75 will be tested with 15. So is 75 equals to 15? No, right? So then again the body of this if block will not be executed, and then again I will get the counter variable I will get incremented by 1. So 1 plus 1, 2. So now the value of I is 2. Now this is just for to make you understand, okay? Actually initialization is only done once, okay? So here I becomes 2, 2 is less than 5. Again test the condition, okay? So again 75 is equals to 7. No. So again I gets incremented, okay? So now after I gets incremented, so 3. So 3 is less than 5. Yes. Then now comparison is done. What value is stored in num3? So is if value 75 equals to num3, num3 stores the value 75. So since both are same, so this body of the if block will be executed, that is position equals to I plus 1. So which is I plus 1 is uh, the value of I is now 3, right? So 3 plus 1, 4. So 3 plus 1, 4. So now see how to display search value 75 position is 4. Okay, so which is 1 2 3 4. Okay, so for that reason here it is written here I plus 1. Okay, if suppose if you write here position equals to I, then I will be 3, right? So which will be you will get the wrong position, that is 1 2 3 4, right? And 3, if you write here, if I is 3, so 3 will be 7, right? Now in terms of index, it will come out correct, but in terms of like the textual representation, right, so it won't come out correct. So that's why here it's written I plus 1. Now here POS equal to 0 is initialized, okay? So even if you don't initialize this POS equals to 0, okay, a garbage value won't be generated, because here the POS variable is not used in the right hand side of the program logic, right? Whatever is executed on the right hand side is simply assigned to the POS variable. So you can, what you can do is that you can try removing this, okay, and then just declare it. So go through this table dry run method, okay, and see, check we compared with the output. Now sorting array. So sorting is a process of putting a list of data items in a specific order. Sorting can be done for alphabetical or numerical values, either in ascending or descending. So in the previous we have seen that, okay, linear search, right, where you search for a particular value in the array. Now you can, what you can do is that you can sort the values that are stored in the array, either in ascending format or descending format. So in linear search we dealt with unsorted arrays. The array elements were in random orders. But now using this linear sort, we can sort it in either like ascending format, right? So now this sorting method is based on comparing the top element, that is this top element, with all the elements, and exchanging and move the smaller element to the top. So when the comparison is being met, whichever is smaller will move on to the top. So each round comparing the element with the set of elements of array is called a pass. So after each once the top element or that element has been compared with all of the element, that is called as one pass. Okay, that is called as a pass. So next, after that pass, the second element will be compared with the rest of all the elements, so that will become another pass, right? So next, starting from second element, the remaining elements are compared and exchanged in the same manner till all the array elements are sorted and stored. Okay, so now see this diagram here. So here you can see that the values that are stored in the array element are not in a sorted format, or they are neither in ascending nor in descending. So now what happened in linear sort is starting from the top element, the top element will be compared with its adjacent element, right? So with the next neighbor. So 71 is compared with 16. So since 16 is smaller than 71, 16 takes the place of 71, okay, and 71 comes and takes the place of 16. So you can see here. Now again after that, the comparison will be made with the top element with the third element. So here first element and second element is compared. Now first element and third element is compared, so whichever is smaller moves on to the top. So now we have 12, 71, 16. 16 has taken the place of 12, right? Now again, here the first element will be compared with the fourth element, right? So since 84 is greater than 12, so it stays in its own place. Again, 12 is compared with the fifth element, 96. Since 96 is greater, so it stays in its own place. Then 12 is compared with 20. So now since 20 is greater than 12, right, so it stays in its place. So at the end of this pass, you will have the lowest at the end of the first pass, you will have the lowest number at the topmost position in terms of linear sort, right? So as you can see, the rest of the array elements are still unsorted. So at the end of first pass, the lowest value will be in the top element, right? So second, again, it will start since the lowest number has been sorted, right? So now we'll start from the second array element. The second array element will be compared with the third, and then since 16 is smaller, so 16 moves and takes the place of 71. 71 will come down, right? So and second will be compared with third, second will be compared with fourth, second will be compared with fifth, and so what will happen is that by the end of this, the second lowest number will take the second array element, so that is pass 2, right? So again, if you see here, the third element will be compared with the rest of the elements, okay, in the third pass. And so in the end of the third pass, the third lowest number value will be in the third array element. Then in the fourth pass, uh, as you can see that the fourth value will be the will be in the fourth array element. The fourth lowest value will be in the fourth array element, and at the end of the last pass, you will get to retain the arrays element in ascending order, okay, in ascending for order or sorted format. So what you have observed here is that using linear sort, you can arrange the array elements, that is unsorted array elements, in sorted format, that is in the ascending order. And what you'll observe in that with each pass, the number of passes, the last pass will be one less than the number of array elements. So here we have 6 array elements, but the number of passes, as you can see, is starting from 1 till number 5. So we have 5 passes. So at the end of the last pass, we will get the full array elements sorted in ascending orders. Okay, so go through this linear sort and go through this program, okay, and go through this linear search method properly. Okay, if you have any doubts on this, you can ask